Hi, my name is Kate Chapman and this is my presentation on Lab 1. So an introduction, this lab was to determine the approximate excess charge on one piece of tape has on another. We did this by assuming we can treat the long tapes as point charges. In order to do this, we will be using both Newton's second and third law, as well as Coulomb's law, in order to calculate the excess charge. So to start with the experiment, we did some experimentation in the different interactions between the tapes. So first we created a charged U tape and we saw how it interacted with our hand and it was attracted. And then we did a U tape plus a pen that we knew to have a negative charge, and we found that those two were attracted to each other as well. And based on this, we were able to determine that the U tape is a positive charge because they're opposite charges and they're attracted to each other. And then furthermore, we did two U tapes and saw how they interacted and they were repelled from each other, which makes sense because like charges repel. So going on, we started to do some measurements and calculations. The length of my tape B was 0.22 meters, and it had a mass of 0.00022 kilograms. And the displacement of B when another charged tape was brought up to it was 0.0032 meters. So you're able to calculate the gravitational force from this pretty easily just by multiplying the mass of tape B times the gravitational acceleration, which is a known constant. And so you're able to get Fg is negative 0.002156 newtons. And since the tape isn't moving, we know that the forces must be at equilibrium. And we were able to figure out that the only two forces acting on the tape are the gravitational force pulling it down and the electric force pushing it up. And thus, the two must be equal to each other. So we're able to say that Fe plus Fg equals 0, which means that the electric force is equal to the negative gravitational force, which results with us finding the electric force. From there, we have to make a couple of assumptions, but we can assume that it is all right to treat a long piece of tape as a point charge, and we are able to assume that the two U tapes have the same charge. From there, we're able to simplify the equation, Coulomb's equation for electric force, by squaring the two Q's, by changing the QA and QB into just Q squared. And from there, we can solve for Q, plug in our numbers, and get that the charge of the tapes must be 1.566 times 10 to the negative 9th coulombs. And then from there, we're able to find the number of electrons because the overall charge is Q, what we just calculated. And if we divide that by the known charge of an electron, we're able to find that there must be at least 9.79 times 10 to the 9th electrons. So then we wanted to find the excess charge. In order to do that, we first had to calculate the number of atoms. We did this by dividing the length of the tape by the known length of an atom. And then from there, we're able to divide the number of electrons that we just calculated by the number of atoms to get that there's a 4.45 excess. So then some final questions we have with this lab. What if the electrons had a positive charge and protons had a negative charge? What would that change? So the results would be the same because the tape would still be attracted to neutral charges whether or not it's positively or negatively charged. And since the tapes have the same charge, it doesn't matter whether or not they're both positive or both negative, because no matter what, they're going to repel each other because like repels like. So the results would be the same. Why is it important to handle charged tapes as little as possible? This is because part of the charge is lost every time you touch it, and the charge will transfer to your hand. So it's best not to touch it as little as you can. So my GlowScript code is uploaded as well to Canvas, but this is just the overall view that I resulted in when I ran it. As you can see, it was able to get the same numbers that I did. In this, the electric force, so in this visual representation, the red dot is tape B and the green dot is tape A. The blue arrow upward is tape A's electric force on tape B, and the orange arrow pointing downward is the gravitational force exerted on tape B. Thank you for watching my video. Have a nice night.